Okay, so today we're doing conditional probability. Okay, so conditional probability is when one thing happens first and something else happens after. Okay, for example, what if I don't know, we'll just explain it that way, then we'll go from there. So it's when the first action affects the probability of the second action. Okay, so let's say you have cards spread over the table. I pick up a card, I look at it, and I don't put it back, and I grab the next card. Okay, that's conditional because it conditional. The second action depends on the first action. Okay, it changes the probability of the first action. So the formula here is, I'll write it over here as well. Right over here, let's start up. So the probability of B happening given A happen. So this little line here means given. Okay. This here is the first action, and this here is the second action. Okay. So that equals the probability of A and B happening divided by the probability of A happening. And the big thing here is this here has to match this here. So whatever happens first is in this position here, that is what's on the bottom here. Okay? Those always have to match. Okay, so this is the given formula. So the way it reads is probably be given that A happened. So if I go over here, same thing written out, but just a little backwards here. Now, you can see here I have it written out. This is a probability B given A happens. So it's B, what's the probability of A and B happen, divided by the probability of A. Okay. Now here, it's probability of A happening given B happened. So it's what's the probability of A and B divided by probability of B. Since B was the first thing that happened here, then B has to be on the bottom here. And a little note, the probability of A and B happening is the exact same thing as saying the probability of B and A happening. Those are the exact same thing. Okay? Along those lines. So take a moment and you can write that down. And on your formula sheet, there's a given section. And that's where you want to be there. So let's do an example using this. Okay, so I'm going to erase this because I don't like this part. I like giving, actually I like that part. So suppose in Mathville, the probability that a day will be both cloudy and rainy is 25%. Suppose further that 50% of all days are cloudy. Determine the probability that it will rain given it is cloudy in Mathville. Right. So this here, if we write it out, we're looking for this to happen, the given part here. Okay, so here's our given part. So our probability here is going to be, what's the probability that it rains given it is cloudy? Okay. So that's going to equal the probability that it's rainy and cloudy divided by, and we take a look here, what's our second option here, or the first thing that happens is this. I'm going to erase that actually and put that in blue. Probability it rains and it's cloudy, and that is the probability, let's go purple, the probability it is cloudy. So if we take a look here, if I'm looking for the probability it's cloudy, we have this here, that's 50%. It's cloudy. And then my blue is going to be cloudy and rainy is 25%. So my answer here, if I work side, let's go down. So the probability it is cloudy and rainy is 0.25. And my probability that it is cloudy is 0.5. So that is going to equal, the answer here is 0.5. 0.25 divided by 0.5 is 0.5, or 50%. Okay? I'm going to skip by here. I'm going to go down here. We're going to do another one. All right, so a person is chosen random from shoppers at a department store. If the probability if the person's probability of having blonde hair and glasses is 2 out of 25, and the probability of wearing glasses is 9 out of 25, determine the probability that they wear glasses, their blonde hair, given they wear glasses. So we're looking for the probability they're blonde, given they wear glasses. So that equals the probability of blonde and glasses divided by the probability, and we take a look here, what's here? That's what's going to go underneath here. The probability they wear glasses. So the probability they are blonde and wear glasses is right here. 2 over 25. 2 over 25 divided by the probability they wear glasses is right here. Oops. Is 9 over 25. And we can work that out. For those who don't know, you probably have a fraction button on your calculator. 2 over 25 divided by 9 over 25 equals 2 over 9. And what's 2 over 9 as a fraction or decimal? 0.22 or 22%. Okay? So we're kind of just plugging and playing here. Let's go here. Okay, the probability Charlie wearing his hat is 90%. The probability that Charlie is late and wears his hat is 75%. What's the probability Charlie is late given he's wearing his hat? So the thing here is always look for these words. Yesterday we did or, today we're doing given. So what's the probability he's late given he's wearing a hat? Equals the probability he's late and is wearing a hat divided by the probability, if I look here, hat, he's wearing a hat. So that's going to equal probability he is late and wears hats right here, which is 0.75 divided by the probability he's wearing a hat is 0.9. So that's going to be 0.75 divided by 0.9, which equals 5 over 6, which equals 0.93 or 93%. Correct? Oh, 83, sorry. 83%. Do we have one here? All right, there we go. So, the probability that the complainer rolls her eyes when she sees the math teacher is 82%. The probability rolls her eyes and is playing a game on her phone is 65%. What is the probability that she's rolling her eyes given? Okay. Rolls her eyes given she's playing cards. Playing a game on her phone, sorry. So looking here, probability that she rolls her eyes given she's playing a game on her phone would equal the probability of her, let me think here, rolling her eyes and is playing a game, divided by the probability she's playing a game on her phone. So that equals, probability she's rolling her eyes and playing a game is right here at 65%, so 0.65. The probability she rolls her eyes is 82%, so we're at E2, which equals 0.65 divided by 0.82 equals 79. 0.79 or 79%. Okay. One second here. My computer isn't charging for some reason. There we go. So, the other thing we can do with this formula is, I gotta check my time. I have to get going. Is I can rearrange it to be and. So this is your and formula. So probability of and is probability of A and B happening is probability of B given A times probability of A. So take a second, write that down. That's your and formula for conditional. And we can do a couple of questions with that. So what's the probability of drawing two aces and a well shuffled deck? First card isn't replaced. So we're looking for the probability of drawing ace 1 and ace 2. So that's going to be the probability of ace 1 times the probability of picking ace 2 given we picked ace 1 the first time. Well, the probability of picking ace 1 would be 4 out of 52. There's 4 aces in a deck of 52. Now, the probability of picking ace 2 given we picked ace 1, logically, if we don't replace it, there's 3 aces left out of 51 cards left. And that's going to be my answer there. So 4 over 52 times 3 over 51. No, I just pressed something on my screen. 1 over 2. Get over here. 1 over 221, I think was the number I saw, which is 0.004. 0.0045 times that by 100 is 0.4% chance. Okay, let's do another one that isn't. Okay, Charlie goes hunting. The probability he sees a deer is 40%. The probability he sleeps given he sees a deer is 60%. What is the probability that Charlie will see a deer and fall asleep? So we're looking for the and word. Okay. Really, I should keep consistent and do this in blue. So we're looking for that and word there. So what's the probability Charlie sees a deer and falls asleep? So that's going to equal the probability of him seeing a deer times the probability of him falling asleep given he saw a deer. In this case, I didn't do my colors. This should be probability of seeing a deer given he saw. Perfect. This is going to be my purple. So the probability he saw a deer. Probability he sees a deer is 40%. So 0.4. The probability he sees a deer given, so he falls asleep given he sees a deer, is 60%. So we're going to go 0.6 times 0.4. 6 out of 25. 25 or 0.24 or 24%. Last one here. Tricia was a student in my class who loved Dr. Pepper. So probably that Tricia has a Dr. Pepper is 50%. The probability that she will be sassy given she has a Dr. Pepper is 99%. What's the probability she has a Dr. Pepper and is sassy? Okay, so we're looking for the probability she has a Dr. Pepper and is sassy. So that's going to equal, I'm going to fill out this one first, probability that she's sassy given she got a Dr. Pepper. Okay, and that would make this one be the probability of Dr. Pepper because those are two N1s. So probability she has Dr. Pepper is 0.5 times the probability she is sassy, which is 0.99. It should be 0.49. 0.5 times 0.99 equals 0, pretty much 50%. 0.5 or 50%. Okay, so there is your given formula. Okay, there's your given formula and your AND formula. Both are conditional.